So hello everyone. I am really excited to speaking with Shamim today. My name is Nigel LeBranc and I am the CEO and founder of Cyber Warrior Network, where esports meets cybersecurity. So essentially we've created this game and you can think of it as Call of Duty but for hackers. And while folks play the game, we validate their knowledge, skills, and abilities, and we can match them up to real world job opportunities. And I'm excited about this conversation because we're going to be talking about confidential computing in esports, and a very special guest here today. I'm really looking forward to our conversation. So Shamim, why don't you tell people a little bit about yourself and about your company and what you do?
Yeah, so my name is Shamim Naqvi. I'm the CEO of SafeLiShare, which is a company. It's about a year and a half old. It's a startup company. We are interested in securing computing workloads and using trusted execution environments. This whole genre of technology goes by different names. Sometimes it's called trusted execution environments, and sometimes it's called trusted computing and confidential computing. And some people have also referred to it as secure enclave technology. But the basic idea is still the same. You protect the computation when it's happening at runtime, and you make sure that there is no external intrusion into the computational process, and you make sure that the assets that are used in the computing are always protected.
So Sharman, when you say confidential computing, and by the way, thank you for kind of explaining that, but for the regular gamer or even just somebody using their computer, what are the things that they should know about this? Like in very simple layman terms, and if there's an analogy that you can use to kind of describe that, we'd love to hear that.
So the simplest way to understand this is the basic idea that computing typically involves one or more data sets and an application or a code base that computes on that data. Oftentimes, the data is provided by one party, and the code that processes the data is typically provided by a second party. Or the code base generates the data, as in a particular games situation, the data may be stemming from the running of the game. Now, since these assets, the game assets, the code base, etc., are typically coming from different parties, you have different constraints or different policies that relate to the security of the assets and the security of the code base. So you may be concerned from the code base point of view that the code base is not being hacked, has not been changed from some baseline version. And the players may be concerned about their user identities being known, swatting attacks being made possible, game scores being changed, etc. So all of those constraints and all of the concerns that the various assets have combined together mean that you need to assure that the computation that is represented by the running of the game is secure, can be trusted, the results of the game can be trusted, and there is a notion of fair play that can be engendered from the running of the game.
Wow, this is really interesting. So let's see if I understand this. So you brought up, you mentioned swatting, right? And folks, for those of you guys who don't know, swatting is when somebody calls in a fake attack or fake scenario, and they literally call the cops or the SWAT, and they will respond. So this has happened before multiple times, but there's one case in particular where the perpetrator was sentenced for 20 years because it resulted in the wrongful death of actually it wasn't even the person that was playing the video game, it was somebody else. So person called the cops, gave them an address, and inevitably that person ended up being shot and killed because the cops thought that they had that he had a gun. Really sad situation. So, Charmaine, you're saying that with confidential computing, as far as it pertains to gaming and esports, there's a way to actually protect your identity of multiple users while you're playing online?
Yes, absolutely. So there are various ways to do it. One way would be a new piece of technology that goes by the name of IBE, identity-based encryption, and it has an extension called wildcard identity-based encryption. What that means is that I can take your email address, let's say, for instance, or some other publicly known handle that you have, and I can use it as an encryption key to encrypt the communications between you and the game server.
Okay.
This means that a public key is generated using your public information, which can only be decrypted by you using a private key from the game server. Now, what is interesting is that SafeLiShare did not invent the idea of this type of encryption. But what is interesting is, and in fact, this particular type of encryption has been known for many years. But what is interesting is that a weakness of this approach is that the game server will hold the private key for your public key. And that private key will be used to decrypt your game data and all your communications, which of course is very powerful. However, in the case of SafeLiShare, if you run the game server in a secure enclave environment, what happens is that the private key is protected by the confidential computing hardware. So therefore, your key is absolutely safe, and your IBE, your secure communications that are secured by using this type of encryption would be completely unhackable by any third party. So yes.
That's really interesting, because oftentimes when you think about solutions like this, and even I learned this not too long ago, that secure computing is not just a software capability. It also kind of goes into the hardware as well, that you kind of alluded to, right?
Absolutely. So, yes. So what has happened in recent years is that hardware manufacturers have started to build first into the firmware and now into the chipsets and into the CPU instruction sets certain features of cryptography. Mm-hmm. And so what this means is that fundamentally the hardware attests itself and creates these completely protected and isolated computing environments. So parts of memory which are dedicated to being protected and isolated from any process that is running on that machine, to the extent that even the OS and the supervisory programs on that machine, the so-called hypervisors, etc., if you are using that, cannot get into that piece of memory. So whatever is running in that protected and isolated piece of memory is completely free of all kinds of any and all kinds of intrusive software. Only the game server and the game players have access to that particular type of environment. So these are hardware-based capabilities that are used by software to protect the workloads that are being computed. A very sort of interesting aspect of confidential computing is that when you use these secure enclave environments and you house a computation in them, there is typically an audit log that is produced with the help of the hardware, which contains all the information, so you can know exactly what computation took place, who the actors were in that computation, and everything was protected, and which keys were given access, which entities with keys were given access to the data. So you have, in some sense, a completely immutable log of the computation or the game state as it was being played at runtime. which you can take to the regulatory bodies or you can present to anybody. And there are all kinds of verification tools that allow you to verify that this is in fact a true and accurate depiction and record of the game that was secured and protected in this confidential computing environment.
So we've been hosting tournaments at DEF CON, and during our first tournament, we had a couple of people hack the leaderboard, right?
Yeah.
And we get into the back end on the server, and we're realizing like, hey, this person has maybe 2 or 3 completions in terms of actual mission completions in the game, but they're way ahead of everybody else. And you've mentioned the terms secure enclave and the trusted execution environments. Can you tell us how you would implement or how that technology could kind of safeguard from instances like that?
So the interesting development in electronic sports and games in the last 10 years or so, I think a major development has been the use of online game platforms that have allowed scalable computing to happen, or scalable amount of resources to be brought to the game. So if thousands or multiple tens of thousands of people get sort of involved, you can scale your underlying set of resources sort of accordingly. Confidential computing is the cloud's answer to providing runtime security. So on Microsoft Azure, Google Cloud, and on AWS, particular specific machines are now generally available that allow applications to provision clusters of those machines on demand, if you want, and use those machines and their cryptographic capabilities to create these isolated and protected environments. They go by different names, as I mentioned before, but essentially the basic idea is the same. You create protected, isolated environments in which you run computer programs, and the computer programs and the protected, isolated environments in which they run provide a hardware root of trust that the computation is secure, that the results of the computation can be trusted, and you can rely on the state of the game and the state of the computation to be preserved securely. And so that is what is, I think, sort of exciting, that you have scalable computing resources being made available, and coupled with the guarantees that come from trusted execution environments, from secure enclaves, you now have the possibility to have scalable, online, secure, trusted gaming platforms.
So with those trusted platforms, kind of going back to our experience, right? The leaderboard, which is totally separate from the actual game platform itself, that was hacked, right?
Yeah.
So you're saying that this solution here could actually prevent that from occurring, because you have this trusted environment which is totally separate from the actual code that's being executed for the actual game completion. Yeah. But you can also secure just the, for lack of a better term, the data feed of information from the actual gaming server that passes the data to the leaderboard. You can secure that as well.
Yeah, the leaderboard is a data structure that is constructed from the state of the game. Mm-hmm. It changes and shows the scores and the various outputs of the game state, the various set of attributes of the game state. But it is, of course, entirely possible to completely encrypt the leaderboard itself and have it maintained and processed from within by computing programs from within the secure enclave, so that the leaderboard can't be hacked unless you can hack inside it, hack and change the process that maintains the leaderboard inside the secure enclave, which is not possible.
Really enjoyed the conversation. Looking forward to having more of these conversations. I think this is far-reaching, man. There's so many things that we can talk about. Even supply chain, right? Logistics. There's so many. So I'm looking forward to continuing this conversation. Thank you for being here with us, and we'll sign off here.
Thank you, Nigel, and thank you for asking wonderful questions.